Hello everybody and welcome. Thank you for turning on the second episode of our new Bosch Thermotechnology Expert Talks. Today, our topic will be carbon neutrality at Bosch Thermotechnology. My name is Thomas Pelitzeus and it is my pleasure to guide you through the event. Since people are still joining, let me start with a few words about the idea behind this series, for those who have not joined the first talk on hydrogen in November. With annual sales of 3.5 billion euros, Bosch Termotehnică is one of the major international suppliers of HVAC systems. We offer system solutions for indoor climate, domestic hot water, and decentralized energy management. We provide highly efficient technologies, many of which use renewable energies and make an important contribution to reaching the climate targets. At the same time, we deal intensively with the enormous changes that the building sector and the heating market are facing on the way to climate neutrality. In the expert talks, we would like to give you an insight into our ideas on these changes and discuss them with you. Therefore, we would like to invite you to enter questions in the chat window. We will do our best to answer as many of them as possible at the end of this session. Two technical remarks. I would like to point out that the whole session will be recorded, and if you have any technical problems, please try to reload the page by pressing the F5 key on your keyboard. Pressing F5 helps in most cases. Well, today we will have a closer look at carbon neutrality. From our point of view, when it comes to the climate, words are not enough. We need deeds as well. One of our key messages to our customers is that replacing old boilers and buying one of our new appliances is an important step towards climate protection. But at the same time, we ourselves want to contribute to carbon neutrality and even be a beacon in this topic. Therefore, I'm very happy that 5 of my colleagues will today elaborate on this position and give concrete examples from our sites, as you can see in the invitation. Uwe Wild will start and give an overview about carbon neutrality implementation at Bosch Thermotechnology. Then we will have 3 case studies, starting with Mike Cope from our Worcester plant, followed by Diogo Salta from our Lolla plant, and Vitaly Bulda from Ukraine. And Friederike Neugebauer will finish with giving an outlook on what are the next steps. But let's have a start now. I wish you some interesting insights and a fruitful discussion, and I'm happy to give the floor to Uwe Wild.
So, hello. Good morning. I'm Uwe Wild. I'm an engineer. I'm an engineer for the supply of gas, water, heat, cold, and so on. I'm an energy consultant, and for more than 10 years, I'm leading the energy efficiency activities of Bosch Termotechnology. I'm really pleased to participate today in this expert talk and to have the opportunity to present to you our activities for climate protection. This is our biggest goal. We will reach carbon dioxide neutrality not just by 2050, but by 2020. We're struggling hard, and I'm pretty sure that we're on a good way. And an auditing company will certify that we really reach this carbon dioxide neutrality after the end of the financial year 2020. On this slide, you can see the scopes we're working on. I rather stand for scope 1 and scope 2. This is what happens within the fence of our sites, within the manufacturing and development of our sites. Scope 1 is the direct combustion of fossil fuels as gas, fuel, and everything we need for our vehicles, our service cars, for example. And scope 2 is the usage of electricity or district heat we need to manufacture our products. What you can see now are the 4 levers we're working for. We're busy with to realize this carbon dioxide neutrality. I will show you on the following slides. The first one, and the most important one from my point of view, is energy efficiency. Until Bosch set itself the goal to reduce the energy consumption, to realize energy efficiency activities of about 1.7 terawatt hours until 2030. The part of Bosch Termotehnică is 57.3 gigawatt hours until 2030. This is more than 20% of our energy consumption of our base year 2018. And the current status is, I'm really proud about, that we already reach until the end of this year energy savings of more than 18 gigawatt hours since we started this project in 2019. That means we already reached our goal for more than 30%. The second lever we're busy with is the so-called new clean power. Bosch set itself the goal to produce by our own until 2030 400 gigawatt hours carbon dioxide free electricity, mainly on photovoltaic installations. As you can see on the slide, this is the roof of a plant in India. And the TT part of these 400 gigawatt hours are about 13.5 gigawatt hours we have to bring until 2030. The current status of Bosch Termotehnică is that we will inaugurate our first photovoltaic installation in the first half year of 2021. We already have a lot of older facilities, but from the start of the new project, this will be our first facility due to a longer planning time and the time we need to get all the permits of the authorities. The second part of this new clean power is, as we can't produce all the needed electricity by our own, second part is to invest in long-term contracts with external companies to build up carbon dioxide-free electricity, mainly with wind generators and PV installations. The third lever we use to realize carbon dioxide neutrality is the purchase of electricity, of green electricity. In Germany, we already since 2019, all German sites of Bosch and Bosch Termotehnică use green. That means carbon dioxide-free electricity, and we're pretty sure to realize this until 2020 for all Bosch sites worldwide. The remaining rest of carbon dioxide emissions that comes from fossil combustion to heat up our plants, the fuels will be compensated on a plant level. On the next slide, I give you 4 examples for the activities we realize within our sites. For example, the Bosch site, the TT site at Wernau in Germany. There last year we optimized a coating line, and that saves 420 megawatt hours gas every year. And energy efficiency measure we realize in all sites is the replacement of old lighting tubes by high efficient LED lighting systems. Within the last 5 years, our activities here will save more than 2,600 megawatt hours per year. Another important measure we use is the heat recovery from waste heat. And there, within the last 5 years, we realized energy efficiency projects that saves more than 8,500 megawatt hours per year. The last example from my side is, I already mentioned it, the PV installation of photovoltaic in our site Aveiro in Portugal. In the first half year next year, we'll inaugurate a facility with 1 megawatt hours peak. This will cover about 20% of the site electricity consumption. So thank you very much for your attention now. And now I'll hand over to my colleague, Mike Cope from Worcester.
Yes, thanks for that, Uwe. First of all, good morning from Worcester in the UK. My name is Mike Cope, and I'm the facilities manager here at Worcester Bosch. What we do here, we make domestic gas boilers for the UK market, and we're the UK market leader. Next. Yes, so the original factory here was built in 1990, and part of the original infrastructure was the installation of 8 train AHUs to provide fresh air and heating to our production hall. The heating was provided by direct-fired gas burners, and the controls infrastructure was, well, very primitive by the standards we have today. Basically, the gas burners could either be 50% on or 100% on, and the system fans could either be on or off. We estimated the overall efficiency of the system as 75%. And this was gradually degrading as fan motors started deteriorating and damper blades started breaking off the Belimo valves controlling the fresh air intake. In 2018, we invited a carbon consultant to audit our site, and the replacement of these units was pretty much at the top of the list, really, in terms of recommendations in their report. Next. So what we did, we obtained funding through the Central Bosch Energy Efficiency Fund, and we've now replaced the original AHUs with 4 inverter-driven roof-mounted units. The heat source we get from our very own Baderas GB402 condensing boilers, which have a DIN seasonal efficiency rating of 110%. Advantages from our new system here at Worcester, we're recovering heat energy from the extraction ductwork by use of a thermal wheel. We've installed CO2 monitors in the production hall to make absolutely sure we introduce the optimum amount of fresh air through the system. We can also utilize control in the area to make sure that we program the heating and the fresh air to the actual occupancy related to our shift pattern. So we're not heating areas that don't need to be heated, basically. But I think the most important thing really to say is we now have far more control over our heating and fresh air intake. As an example, integrated heating coils have a two-part control valve. So as the flow gets throttled back, the circulation pumps will reduce speed and energy demand. And also, I'll have to say, as a facilities manager, it's far easier maintaining the new air handling units on the roof rather than the rather precarious access we had to the old units above busy production lines. Next. So really summing up this project, we estimate our air handling unit system, our new one, has an energy efficiency of 92%, and this will save us 306 tons of carbon a year. My consultant tells me that this is equivalent of driving a diesel car 1.8 million kilometers. I haven't tested that, I take his word for it. Also, we're saving an estimated 53,600 euros on our site electricity spend, which is an annual saving of around 10.8% and saving 193 tons of carbon a year. On the gas side, we are saving an estimated 10,500 euros, which is saving on our overall consumption of about 9.5% and 113 tons of carbon a year. We haven't stopped yet, though, because we're looking to make further benefits in terms of the system. What we want to do is recover our waste heat energy from our water recycling scheme, which is linked to our boiler testing program. I think that's basically our AHU replacement project here at Worcester. Next. So it's a thank you from me at Worcester, and I'll now hand over to my colleague Diogo.
So thank you very much, Mike. Good morning, everyone. My name is Diogo Salta. I am a project manager at Bosch Termotehnică since around 10 years. And I am additionally also a CO2 coordinator for TT. And I am the project manager for the new waste heat boiler in our TT site in Lollar. First of all, I would like to thank all the participants for your interests, and a special thanks to Thomas Pelitsas for this invitation to present the project at the Bosch Termotechnology Expert Talks. It is a pleasure to be here. So at the site of Lollar, mainly cast iron boilers and brake discs are manufactured. In this location, both Bosch Termotehnică GmbH and Robert Bosch Lollar Goose GmbH are represented. In the past, part of the waste heat, however, due to the increase in production in the foundry, an additional potential was identified to use approximately 4 times more waste heat from the foundry than before. This new project concerns the installation of a new waste heat boiler in 2020, which has more capacity and efficiency than the old waste heat boiler. The investment costs amount to approximately 1.9 million euros, with an estimated cost savings of 240,000 euros per year. So both the buildings from the thermotechnology side and from the Lollar Goose side are supplied by a central heating network that covers most of the area of the Lollar site, which means approximately 75% of the whole location. It concerns the buildings in blue color that you see on the slide. The heat is generated centrally in the boiler house, so the light blue dot that you see in the building. And this is made through 7 boilers, a combined heat and power unit, and a compressed air heat and power plant. The total installed capacity, heating capacity in this boiler house is approximately 13 megawatts. This is excluding, of course, the capacity that the waste heat boiler now brings to the system. So as you can see, in the building of the foundry, we have the darker blue dot where the waste heat boiler was installed. And this waste heat boiler is connected hydraulically to the boiler house that is the light blue dot. And from this point, there is a distribution to the buildings where the waste heat is then used. Just giving a very short explanation of the waste heat generation process. So an essential part of the process in a foundry is the melting of metals and the production of cast iron. In the site of Lolar, a cupola furnace is used where layered raw material, metal and coke are melted by embers, with hot air being furnace gas, which is then burned afterwards in order to clean up the particles and emissions, generates a large amount of waste heat, which we will then use in the waste heat boiler. And this is the part that you see here on the right. It is the part of the process that is dependent or controlled by Bosch Termotehnică, where we use the waste heat from the foundry. So this diagram that you see in front of you represents the waste heat boiler, which is essentially a large heat exchanger that enables the waste heat present in the exhaust gases of the foundry to be transferred to a water glycol system that is connected to the existing heating network. So using exhaust gases at 720 degrees Celsius from the foundry, the waste heat boiler has a thermal output of around 7 megawatts. On the water side, as you see in the diagram, the water glycol mixture is heated from 100 degrees to 130 degrees, and the heat is then transferred to the heating network of Lolar through the boiler house. So for this project, it was estimated that with the new waste heat boiler, a total of approximately 9.7 gigawatt hours of energy per year could be recovered. This provides TT a saving of 1,522 tons of CO2 per year. Coming to the end of this presentation, I want just to let you know that the dismantling of the old waste heat boiler began in December 2019 in parallel with the installation of the new waste heat boiler. And this whole process took around 9 months. So in the pictures, you can see the assembling process of the waste heat boiler on the left, where you have the cranes. In the middle, you see one of the modules of the waste heat boiler, which is essentially a big heat exchanger. And on the right side, you see the waste heat boiler already assembled and in operation. This is a unit that is approximately 12 meters high. So this was all from my side. Thank you very much for your attention. I wish you a nice time, nice holidays, and a happy new year. And I hand over my presentation to my colleague, Vitaly. Thank you very much.
Let me just jump in for a second. Thanks a lot, Diogo. I would like to draw your attention to the chat window in the bottom right. There you have the possibility to ask questions. We have reserved some time at the end of the session to answer the questions, so it would be great to have some. Thanks a lot. Vitaly, sorry, you're still on mute.
Good. Sorry, heavens. Thank you very much for the opportunity to present some result of our job in Ukraine. My name is Vitaly Bulda. I am responsible for Bosch Ukraine as a company, and as well, I'm a sales manager of the region. Today I will present you some projects which we made in Ukraine to reduce CO2 pollution. And first of all, I must say that the projects mainly are based on the solar thermal collectors. As you see, Ukraine is located in the middle latitude of Europe, thus solar irradiation is enough for usage of solar thermal collectors for domestic hot water and, unfortunately, not for the heating. Besides this, electricity prices are much more preferable as for natural gas. Thus, heat pumps are the right solutions for the heating. And we are using normally the combination of solar and heat pumps to reduce CO2. The picture I like very much because, as you see, the solar collectors can work even in the difficult situation. You can see that the snore can go down a little bit by increasing of the temperature. We can measure all these functionality of the solar collectors by the Bosch Easy Control system. And as you see, by the outside temperature of 3.5 degrees above zero, we have temperature of the collector 25.6, which means that we can use it for the domestic hot water. And I can tell you that only 2 collectors saved for in 2 seasons, 2019, 2020, already 2,000 cubic meters of the neutral gas. But it's a peanuts, but we can explain you how you can use the solar collectors. The opportunity to make a big project with solar collectors appeared when our company moved to the new office building, and we rented the 7th floor with the aim to install on the roof the solar collectors. But unfortunately, the roof of our building was not really good oriented to the sun. Thus, we used another building, neighbor building from the same office center, to install 40 collectors, 40 solar thermal collectors for domestic hot water, and we are using south directions and as well reflected beams from the river. What we are doing with 22 cubic meters of water per day, we are just selling it. We sell the water to our landlord to 3 swim pools, 15 showers, and we are covering 90% of the month of June from May to September. As you see, it's an ideal construction which we have here, and the project is really unique because we realize it in the building already operating in 100% of capacity. But it's Kyiv, it's a big city, we can do a lot of big projects, but what we are doing in the regions, all our regional subsidiaries in Lviv, in Odessa and Dnipro, we just cut it from the neutral gas, and we are using gas only for training or LPG for training purposes. And we are using standard package of heat pumps and solar collectors for domestic hot water and for the heating for the whole office, means for the office as well, for the training and for the warehouses. And now I please your attention to the short video spot about the project. Thank you very much. Thank you very much for your attention. And now I would like to hand over my presentation to my colleagues, to my colleague Friederike. Please, Friederike, your turn.
Yes, hello, good morning. Thank you, Vitaly. So also from my side, thank you very much for joining this talk in the week before Christmas. I'm happy you found the time, and I'm honored to spend the next few minutes with you and the question, what are the next steps? So my name is Friederike, and I do design for environment at Bosch Termotehnică, which includes a lot of different environmental topics, amongst them the Scope 3 emissions. So the focus is really coming on the entire value chain now, especially on our products. And in the next few minutes, I will explain to you what those Scope 3 emissions are, what we have learned about them so far, and how we want to reduce them. So here you can see the same picture that Uwe already showed in the beginning. And you can see in the middle scope 1 and 2, the emissions that result from activities within our own facilities. But we also have scope 3. And scope 3 sums up all the emissions that stem from activities that are upstream. So everything that comes towards our factory from our supply chain. It includes logistics, it includes purchasing and several other activities. And then also we have the downstream side of scope 3. This is everything that leaves our factory gates. So for example, our products, obviously, but also again, logistics, recycling, and so on. So today I will focus on the emissions from using our products, which is a big share. So in 2019, a bit more than 1 year ago, the Bosch Group joined the Science Based Targets Initiative, which is an organization that supports companies to set CO2 reduction goals that are in line with the science and what science says is needed in order to keep global warming below 2 degrees. So to keep the Paris Agreement. And the Bosch goal in line with science is to reduce scope 3 emissions by 15% until 2030. Now, if you wonder what the reference here is, we compare emissions from all the appliances that we sold in 2018 over the entire lifetime of those appliances in absolute terms. So we compare this number in tons of CO2. We compare it to a simulation of 2030. And for that simulation, of course, we had to take several assumptions. For example, what kind of appliances will we sell in 2030? And where are we selling them to? How many of them? And what will change in those target markets? What will change in different countries? And it was a very exciting thing to do, actually. It's very interesting. And our calculations showed 2 things. So the one is that this 15% target is actually pretty ambitious for us because it's measured in absolute terms. And the gas market is still very important, both within the EU and also outside of the EU. And second, we highly depend on external factors, like building renovation, for example, or also the renewable share in the gas mix. So maybe some of you attended the last ExpertTalk in November. There you heard that there are already a few projects running where entire villages are run on hydrogen only. And if that is possible, then our boilers will run on hydrogen, on green hydrogen ideally, and that would then not cause any emissions anymore. So there you can see how much these product use emissions depend also on external factors. But we accept the challenge, and I will highlight 2 sets of answers that we have. And the first one is technology. Of course, we're a technology company, and we have a strategy of electrification and hydrogen. So maybe you heard that there was a very large invest into heat pumps lately, and we're really building that business up. At the same time, we're also investing in fuel cells and developing those further, as well as hydrogen-ready boilers, which, yeah, as I already said, was discussed in the last expert talks. So, yeah, we're open with regards to the technology, but I think it's safe to say that the needed technology is already there. So it's not impossible to make heating carbon free, or at least reduce the carbon footprint a lot. And the second set of answers is a smart set of answers. So first we have digital services. Imagine, for example, a smart controls that regulate your heating device in a smart way while you're not at home. That can significantly reduce CO2 emissions. And another example is our new business model that we just introduced this year in Germany. and it is now possible to rent appliances. So for example, it's a lot easier now to afford a heat pump because you don't have to make that high upfront investment. You can rent it instead. Also, you get a maintenance contract with it, which makes sure that the efficiency of the appliance stays on a high level. And you also have the option to get a solar system with it and energy management as well. And of course, all of these things have the potential to reduce the CO2 footprint of your heating system as a whole. If we still talk about gas, of course, that's still the majority. And here we also offer a share of biogas. So if you decide to rent a boiler, you can opt in and get a share of biogas in the gas mix. And that, again, directly reduces the carbon footprint of your heating during its entire lifetime. So to sum up, the emissions from product use is really a multifaceted and complex topic. And honestly, we don't have all the factors in our hands, but we want to do everything possible, also together with our customers, to bring these emissions down and to contribute our share to slow down climate change. So we're looking at the moment into sustainability, and the Scope 3 emissions are one important topic in that, as part of that. Yes, thank you very much. Now I look forward to your questions.
Thank you, Friederike. And thank you to all presenters, and also thank you for your questions. I will try to direct them to the presenters, and the first questions go to Uwe Wild. There's one question concerning insulation of buildings. Have we invested in our premises, in our sites, in the insulation of buildings?
At the moment, we focus mainly on economically efficient measures and projects, but we also invest in the insulation of buildings. Yes, for example, at Wernau, where I'm sitting at the moment, we have refurbished a lot of the buildings. This is also a big reduction potential for energy consumption. So we do also this, yes.
Mm-hmm. Okay. Second question, I think, goes also to Uwe. Have you considered the savings of carbon tax? For example, in Germany, we have this 25 euro per ton carbon dioxide tax starting next year. Have we considered this savings in this in our return on investment calculations?
We're sure that the investment in energy efficiency will always be refunded, that we will save energy and costs in energy consumption, and so the carbon tax is a part of it. But in the end, we're sure that anyway that the reduction of energy consumption is economical gain too. So yes, we consider this too. Yeah.
Okay. And there is a number of questions related to the energy that is today being used in our plants. Maybe I can cluster them a little bit. On the one hand, what is the current status regarding the use of green electricity in our plants? And on the other hand, what is the status about gas and oil that is still used today in our plants? Is it compensated? Is it replaced? What is the strategy?
Yes, in Germany, as I mentioned before, we already use only green electricity in all Bosch plants since last year. And within this year, we will realize this status using only green electricity in all Bosch sites globally. And for the heating of our buildings, of our sites, we still have vast sites with some 1,000 associates. We still use gas, fuel oil, and so on. But wherever we have opportunity to replace this by heat recovery from our processes, for example, we also proceed to use more electricity, to heat green electricity, to reduce our energy consumptions and our emissions too on this field. Yes.
Okay, thank you, Uwe. Next question goes to Diogo. Does the waste heat boiler also use condensing technology, like the residential boilers do?
No, this technology is not available at the waste heat boiler.
Okay, thank you. And there's another question directed to Vitaly, I think. What effect does the economic situation in Ukraine have on the achievements of carbon dioxide goals, Vitaly?
I think it's very difficult. We don't have no help or support from the government for such kind of projects. But we must think about the commercial necessity of the projects. And for instance, the projects like we have in our office, it's 3-4 years payback period. That's why we make our contribution to increase energy efficiency of our projects in Ukraine.
Okay, thank you, Vitaly. So I think these are the questions that are related to our carbon neutral topic of today. There are some questions that are a little bit off topic. We will answer them individually. And that means, from my point of view, we are finished. So then let's come to an end. I say thank you to all participants. Thank you for your time. Thank you to all the presenters. And we wish you season's greetings. Have a happy new year. Stay healthy. Take care and goodbye.